Hello and welcome back. The subject of today's lecture is a new quantity called power. Power is going to get the symbol P. And when we talk about power, we talk about the rate at which work is done. So power is the rate at which work, and remember work gets the symbol W, is done. Specifically, it is the time rate. So remember, time gets the symbol T, and so by definition then, power is going to be equal to work divided by time. So first of all, let's look at the units we're going to have for work before we start looking at some examples. So the units for power, remember when I put brackets around a quantity, I'm just talking about that quantity's units. The units for power are going to be the units for work, standard units in the metric system, that's a joule, divided by the unit for time, standard unit is a second, and a joule divided by a second is named a watt. And of course, we're not going to write out that whole word, we're going to abbreviate a watt as W. So the units for power standard in the metric system are units of watts or joules per second. So how is power actually looked at from a more common sense point of view? Well, let's imagine that we have a couple of people that want to run up the stairs. So let's imagine that we have me. So this is me. And then we have the Incredible Hulk. And I may be dating myself here. Some of you may not know who the Incredible Hulk is, but you can see that his mass is much, much larger than mine. So we're going to run up these stairs, and we want to find out which one of us is more powerful. So this is the height of the stairs. And the work that is going to be done as we traverse these stairs is going to be the work that we have to do divided by the time it takes us to do that work. Well, what work are we going to have to do? We're going to have to work against the gravitational field that's pulling down on us. So the work that we're going to do is the force of gravity that we have to counteract upward times how the displacement over which we have to apply that force. So the work that we have to do, so this is the work done by me, and this is the work done by the Hulk. The work done by me is going to be my mass times the acceleration due to Earth's gravity. That's the force I have to apply, times the displacement, and this displacement, notice that I only have to exert a force upward. I don't have to exert a force diagonal along the stairs, just simply upward. In other words, I don't need any force to counteract horizontally. So the only displacement that I'm worried about is the vertical displacement, or the height h. Notice this is also the change in my potential energy as well. From previous videos, you see how work done by conservative fields and the change in potential energy are connected to one another. What about the work that the Hulk has to do? Well, he has to, again, work against the gravitational field, but this is going to be his mass, so that's going to be the mass of the Hulk times the acceleration due to Earth's gravity. That's the force of gravity exerted downward on the Hulk. He has to exert a force upward of that same magnitude, and then times the vertical displacement that he has to experience, and that is the height h. So notice that these quantities are not the same. My mass is much smaller than the Hulk's mass, and so the amount of work that the Hulk does is larger than the amount of work that I have to do in carrying ourselves up this height h. So what about the power? Well, the power I exert is going to be the work I do divided by the time it takes me to do that work. So this is going to be my mass times the acceleration due to Earth's gravity times the height divided by the time it's going to take me to traverse the stairs. What about the power that the Hulk exerts? Well, he is going to have a power rating that's going to be equal to the work he does divided by the time it takes him to do that work. So this is going to be his mass times the acceleration due to his gravity times the height divided by the time it takes him to carry himself up the stairs. So now let's look at these two relationships. Notice that the numerators are definitely different. My mass is smaller than the Hulk's mass. So what is going to determine who has the higher power rating, me or the Hulk, is going to be due to the time difference it takes me versus the Hulk to get up the stairs. So notice that if it takes us the same amount of time to get up the stairs, in other words, these two times are identical, then the Hulk is more powerful than I am in that he was able to do the work in do a larger amount of work in the same amount of time that I was able to do a smaller amount of work. If instead I am able to traverse the stairs faster, then it's going to be dependent on which of these times related to the masses are going to be larger. So the idea of power is not that a more powerful machine can do more work. It's that a powerful machine can do more work in a shorter amount of time than a less powerful machine. A less powerful machine can still do the work, it's just going to take a lot longer for it to do that work. So this sort of gets at the nuance involved with this new quantity called power that we're going to be using as part of our tool bag moving forward from here. So we'll see you next time.